Hi boys and girls, welcome to your next lesson on radiation. Last lesson we looked at the three types of ionizing radiation, alpha, beta and gamma. In this lesson we'll be focusing more on the properties of these three radiations. So you'll know, you already know, but you'll be going over ionizing radiation and how it causes ions. The properties, like I said, in terms of ionizing power, penetrating power, range in air, and what they're absorbed by for alpha, beta and gamma. And you also know the definition of irradiation and contamination. So, to start us off, here is your starter. Pause the video and have a go at these 5 questions. These are the answers you should have got. Please check your answers with yours and correct any mistakes. So let's start with the definition for contamination and irradiation. Contamination is where a radioactive source, and radioactive source means something that actually gives out the radiation, the physical object that is radioactive. So contamination is where the radioactive source, the radioactive stuff, has physically touched another object. We say the object that's been touched has become contaminated with the radioactive source. So this might be on the surface if they've touched or rubbed together, or it might be inside something. For example, if someone swallows a radioactive source of some sort, that's contamination. And here's an example. Chernobyl power plant was a nuclear power station near Russia, which exploded about 30 years ago. The radioactive dust and the stones from that explosion landed on the ground. The ground became contaminated because the radioactive source, the dust and the stones were radioactive, they touched the ground surface, so the ground became contaminated. Animals then came along and they ate the grass that was on the ground, so the animals themselves became contaminated because they now had radioactive dust inside of them. So that's contamination. Irradiation is slightly different. Irradiation means when the ionizing radiation that comes out of a radioactive source, so alpha, beta or gamma radiation, is penetrating through or absorbed by an object. The actual radioactive source does not have to touch anything. It's the radiation that's being emitted by that radioactive source, the alpha, beta or gamma, that if it goes through an object, or if it's absorbed by the object, we say the objects become irradiated. Being irradiated leads to the damage of living organisms, or it leads to the damage of organic matter such as food. Here's an example. If someone was standing near a radioactive source, and the radioactive source was decaying with gamma radiation, the gamma waves would penetrate through their body. We say that that person was irradiated with gamma waves. They're not contaminated because they haven't actually touched the radioactive source. If that person was to walk away from that radioactive source, they'd have no issues and they'll be safe because they're not being irradiated anymore. So irradiation can be reduced if we walk away, if we increase the distance from something, or if we decrease the time that they're in exposure to that object. Right. Please do copy this information down. It's quite important. The definition between contamination and irradiation, and this one comes up quite often in exams. So let's look at the properties of alpha, beta and gamma. These are the main properties we'll be looking at. So for alpha, we've got a description. We know that alpha is 2 protons and 2 neutrons, and we know it's like a helium nucleus. The electric charge of an alpha particle is +2. Remember, it's got 2 protons in it. The 2 neutrons in it are neutral, they have no charge. The 2 protons are positive charged. The relative atomic mass for an alpha particle is 4. It's made up of 2 protons and 2 neutrons, each with a mass of 1. Penetration power means how strongly it can go through things. So we say that alpha is weak penetration. It can't really go through stuff. In fact, it's absorbed by a sheet of A4 paper, or even your skin. So its penetrating power is weak and it's absorbed by sheets of paper or skin. Ionizing effect, we say that alpha is highly ionizing. And what that means is, remember, an ion is where an atom has lost or gained electrons. Alpha, because it's such a big, heavy thing if you think about it compared to other stuff, the alpha particle can easily knock out electrons from any atoms that it collides with. So those atoms then turn into ions. So we say that alpha particles are highly ionizing. And finally, the range in air. What that means is if nothing got in the way, how far would an alpha particle travel through air? Well, it'll only be a few centimeters, because the air itself actually ends up absorbing the alpha particles. And they, because of their mass as well, they kind of end up falling. So they only travel a very few centimeters in air. You will need this information for a couple of reasons. Firstly, we've got some work on this a bit later, but also this information regularly comes up in exam questions. So copy this out, please. Moving on to beta particles now. And we can see that a beta particle, as we know from last lesson, is a single, fast-moving, high-energy electron. Because it's an electron, all electrons have a charge of -1. They're negatively charged. All electrons also have a mass of almost 0. It's so small, it's 1 divided by 2,000. It's 1 over 2,000. Remember, penetration power means how strongly it can go through objects, go through material. Beta is medium penetrating power. It will go through your skin, it will go through paper, but it'll then be absorbed and stopped by a few millimeters of aluminium. Ionizing power, remember, this is how easily you can knock out electrons from any atoms it collides with. It's medium ionizing, beta. It can knock out electrons from atoms. Not as easily as alpha, but it can do. Range in air is a few meters. It can travel a few meters if nothing got in the way. Remember, you'll need this information. Please copy it down. And moving on to gamma. Gamma waves, description, they're a high energy electromagnetic wave. They are not a particle. Because they're not a particle, they have no electric charge. And also because they're not a particle, they have no mass. There's nothing there to weigh. Penetrating power is high. Gamma waves go through almost everything. It takes a lot to stop them. And they're almost stopped by thick lead, very thick lead. They're absorbed by very, very, very thick, in fact, meters and meters of concrete. So it takes quite a lot, because they've got so much energy, it takes quite a lot to stop and absorb them. So their penetrating power is high, and they're absorbed by very thick lead, very, very, very thick lead, or very, very, very thick concrete, meters and meters of concrete. Ionizing effect, they're weakly ionizing. When they collide with atoms, they don't always knock out the electrons from those atoms. So their ionizing effect is quite weak. Range in air, if nothing got in the way of a gamma wave, they would travel hundreds or thousands of kilometers. In space, the range of gamma waves is unlimited. So here's a diagram, an animation showing this. We can see that the gamma wave, the red line, goes through almost all materials, and it's absorbed by very, very thick lead. We can see that the beta particles, that's your gamma right there, the beta particle goes through skin and paper, and it's absorbed by a few millimeters of aluminium. And there's your alpha. It's weakly penetrating, so it can't even go through skin or paper. It's absorbed by them. This same diagram can be represented by this. The arrows show what's happening. So, alpha, weakly penetrating, absorbed by that sheet of paper. Beta will penetrate through the paper, but is absorbed by a few millimeters of aluminium. The gamma will penetrate through the paper, it will penetrate through the aluminium, it will then be reduced by the thick lead. If that thick lead was replaced by meters and meters and meters of concrete, it would be absorbed and stopped. If you would like to do so, please copy this information down. So here's a task. I'd like you to just match up these boxes, one box from each column. So you'll have 3 boxes in a row. They are jumbled up. You should have got something on this. Alpha is the same as a helium nucleus, and it's absorbed or stopped by paper or skin. Beta is a high energy electron. It's absorbed and stopped by a few millimeters of aluminium. Gamma is an electromagnetic radiation, it's an electromagnetic wave, and is reduced by lead. At this point, pause the video and go back to any slide you need to do so. Please fill in this table. This table will summarize all the properties for alpha, beta, and gamma. And like I said, these do come up very often. This is what you should have got filled in. Please compare your table and your information to this one and change or correct anything that you think needs changing or correcting. So by the end of this lesson, we have gone over the properties of ionizing radiation. We've talked about alpha, beta, and gamma in terms of their ionizing, penetrating powers, their range in air and what they're absorbed by. We know the definition of irradiated, the definition of contaminated. And to finish off, I'd like to have a go at these exam-style questions. You should give yourself a good 10 minutes or so to finish these, please. And here's the mark scheme for those exam-style questions. Again, change or correct anything you need to do so. And that's the end of today's session. Thank you very much, boys and girls. Keep well, and we will catch up in the next session. Thanks, guys. Bye-bye.